Hello, hello dear students. So today we are going to discuss the practical on verification of Thevenin's theorem. As I have already discussed regarding the Thevenin's theorem in the class, that the statement of the Thevenin's theorem and the step-by-step procedure how to solve the Thevenin's theorem. So today we are going to verify this Thevenin's theorem practically. So we have discussed one numerical in the class regarding the Thevenin's theorem, and you have also calculated the readings or the values for the same. So this is the numerical that we have already discussed in the class regarding Thevenin's theorem. So I have also told you how to solve or step by step procedure to solve the Thevenin's theorem. Now as we know that any DC network can be solved with the help of any theorem. Means you can calculate a particular value. For example, you have to calculate the load current flowing in the load resistance. So you can calculate that value using Thevenin's theorem. You can calculate the value using superposition theorem or Kirchhoff's law or maximum power theorem or Norton theorem. So today we are going to calculate the current flowing in the load resistance using Thevenin's theorem, and we are going to verify the same practically as well as theoretically. The theoretical part we have already discussed in the class. We have seen the numerical. I have also explained you how to solve this particular numerical step by step, and you have the values. Now here once again I will discuss the circuit. This is the circuit diagram. So here you can see that there is one source, two sources are there. One source is of 110 volts and second source is of 220 volts. So there are three resistances, 100 ohm, 300 ohm and 200 ohm, which are connected as shown in the diagram, and you have to calculate the current flowing in the load resistance, that is 500 ohm. Let that current be IL. Now as we have seen or as we have discussed the step by step procedure. So first step while calculating the Thevenin's theorem is to find the VTH. Now VTH is nothing but the Thevenin's voltage. Now VTH, as you can see, there are in this particular circuit diagram, you can see that across the load resistance I have shown VTH. Means point A and B, if across point A and B you place a voltmeter, if across point A and B you place a voltmeter, you will get the value of VTH. You will get the value of VTH. So VTH is nothing but the voltage across the load resistance. Okay, so theoretically we have calculated the value. As you can see, theoretically it was 82.54 volts. Second step, now while calculating VTH, theoretically what we have done, we have removed the load resistance from the circuit. Point A and B is opened and we have measured the voltage across that particular point A and B. Means we have assumed that an imaginary voltage source is there present between point A and B, and let that voltage source be VTH, and we have calculated the value of VTH theoretically, and you have got 82.54 volts. Now step number 2, after calculating VTH, step number 2 is to calculate RTH. Now theoretically while calculating RTH, what we have to do, as I have told you, you have to short the two sources that are present in the circuits. Now here there are two sources, one is 110 volt source and second one is 220 volt source. Both sources you have to short, and you have to open or remove the load resistance. Means load resistance which is placed across this point A and B, that you have to remove, and you have to measure between point A and B the value of RTH. RTH you have to measure. If in form of circuit I have to show, I have already shown you, then also once again I will show you. Means while calculating RTH, this source is shorted. This is our first resistance, this is our middle resistance, this is our third resistance, and this source is also shorted. Second source, this is V1, this is V2, this is R1, R2, R3, and the load resistance is to be opened. लोड रेजिस्टेंस को निकाल देना है सर्किट में से, और इस पॉइंट के बीच में हमें RTH की वैल्यू मिलती है. So this is the theoretical aspect. Now how to, what is RTH? RTH is nothing but, theoretically if you want to see, RTH is nothing but R1 parallel with R3. इसका जो आंसर आएगा, in addition with R2 you will get RTH, that you have already solved in the class. Okay, so after calculating theoretically RTH की value, it will come 275 ohms. Now last step is to find the load current. To find the load current, we have to draw a Thevenin's equivalent circuit and place the values RTH and VTH. So this is our Thevenin's equivalent circuit. VTH is 82.5 volts and RTH and RL are placed in series. RTH is 275 ohms and RL, our load resistance, is 500 ohms. So theoretically you will get the current as 0.1056 amperes. Now these all theoretical values we are verifying practically. So again, as we have used VLab, virtual lab, for superposition theorem, here also I am going to use the virtual lab with the same values placed as placed theoretically. Okay, so we'll directly go to the simulator. Now see step by step. Now this is our circuit diagram that we have already discussed. Here you can see this is 110 volts source, 100 ohm resistance, 200 ohm resistance, 300 ohm resistance. This is our second voltage source, 220 volts, and this is our load resistance. So here one intermediate switch is used. This switch you can see, one is intermediate switch. So intermediate switch is nothing but to remove or place the load resistance. So while calculating RTH, we know that we have to remove the load resistance from the circuit. Now in the Simulink, we take the help of intermediate switch, so that 220 volt source will be active and your load resistance will be removed from the circuit, and across that point you will get the value of RTH. Now step 1 is first simulate. So, okay, now first we will see how to calculate Thevenin's voltage source. So while calculating Thevenin's voltage source, what we have to do? We have to keep switch 1 in power and switch 2 in intermediate. So switch 2 in intermediate means load resistance is removed now, and across that point we are measuring what? Thevenin's voltage. Both sources are intermediate. का मतलब क्या है? That 220 volt source is also 20 volt source is also in power, 110 volt source is also in power, and load resistance is temporarily removed. Okay, so you will get the value VTH is 82.5 volts. Okay, now while calculating RTH, what we have to do? We have to short 110 volt source. Okay, you have to short 110 volt source. You will get, and here theoretically we can calculate. Here theoretically what you have seen just now, I have shown you on the whiteboard that both sources you have to short and then directly you will get the value of RTH. But practically it is not possible. Okay, so in this simulation what I have done, that I have kept second source in power, and across that second source I am measuring the voltage and current, and after you get the value of voltage and current, R is equal to, according to Ohm's law, V by I. So we will get directly the value of RTH. So instead of measuring directly RTH, here in Simulink we are measuring voltage, we are measuring current, okay, with the help of ammeter, and then we are calculating RTH. Therefore I have kept the second source, that is 220 volt source, in power condition. Okay, so you will simulate. So you have got voltage V2 220 volts as it is in power, and current is 0.8 amperes. If I divide 220 divided by 0.8, I will get the resistance RTH as 275. Okay, so this is our VTH, this is our RTH. And third step, the Thevenin's equivalent circuit, case 3, that is the Thevenin's equivalent, placing the all these values. This is our Thevenin's equivalent circuit. Okay, so load current you will get 0.10645 amperes practically. Theoretically also it was same, 0.105, 0.106, which is approximately same. Therefore, hence, as you can see that the theoretical values and practical values are same, hence we can say that the Thevenin's theorem is verified. So is this simulating part interesting? It is very interesting actually. Now here also, as you have practiced in case of superposition theorem, you can change the values. Now we have taken n number of numericals, right, in class. So you can take any numerical, and place the values, replace the values in this particular Simulink. Okay, so that you will get the answer. So this is done from my side. Thank you very much.